All right, so today we're going to learn about the six other identities that we haven't gone over yet. They're the multiple angle identities. They are the double angles and the half angles. So here's just a short proof of how we come up with these double angle identities. We have sine alpha plus alpha. This is a sign of a sum, so we know we can plug this in to the identity sine alpha cosine alpha plus cosine alpha sine alpha. And you notice that these two are really one and the same, so we can rewrite this as 2 sine alpha cosine alpha. So what we end up seeing is that 2 sine alpha cosine alpha and sine 2 alpha are really interchangeable. So we can go both from sine 2 alpha to 2 sine alpha cosine alpha, and from 2 sine alpha cosine alpha to sine 2 alpha, both ways. So the first one we're going to look at is 2 sine 105 cosine 105, and we're looking to build on this structure here. So if we look at this problem, you'll notice that this matches up perfectly with our identity where theta is going to equal 105. So what we're trying to do here is put it in either a sine, cosine, or tangent double angle formula. So we can easily see that this is sine. So we have sine of 2 times theta, 105 degrees, which is going to be the sine of 210. So then we just have to solve from there. The sine of 210 has a reference angle of 30 degrees, so I know that it's going to be 1/2, and then I just have to determine if it's positive or negative. 210's in the third quadrant, only tangent's positive there, so this is going to be negative 1/2. This next one is just a little more complicated. Again, we're looking at sine 2 alpha, 2 sine alpha theta cosine theta. Sorry, theta. So if we look here, this says sine 15 cosine 15. This does not match up perfectly with this 2 sine theta cosine theta. So what we want to do is figure out what we can multiply our identity by to make it look identical to our problem. So if we look at this, here we have a 2, here we do not. So an easy way to get rid of that is to multiply by 1/2. If we multiply by 1/2, we'll end up with 1/2 sine of 2 theta equals sine theta cosine theta. So now we can replace theta here with our 15, and we get 1/2 sine of 2 times 15. And now I'm just going to simplify. 1/2 sine of 30 is going to be 1/2 1/2 equals 1/4. So that's really the most complicated you're going to see because of the fact that the identity does not match up one for one. Here are the cosine double angle identities. You'll notice there's 3 separate possible identities for cosine 2 alpha. And alpha is just a variable. Could be x, could be y. So if we see one of these, there should be a subtraction sign here. Sorry about that. So that's cosine squared alpha minus sine squared alpha. If it matches up with any one of these, we're going to put it back in this cosine 2 alpha. So if we look at this example here, you'll see that it looks just like this second one, where theta is 7 pi over 8. So what we can do now is replace this with cosine 2 alpha, which is 7 pi over 8. So you're going to get cosine of 14 pi over 8 just through multiplication. Now I'm going to simplify cosine 7 pi over 8. I'm sorry, 7 pi over 4. And we know anything over 4 has a reference angle of 45. So I know this is going to be root 2 over 2. 7 pi over 4 is in the fourth quadrant where cosine is positive. So root 2 over 2 is going to be positive, and that's our solution. So those 3 all go back to cosine 2 theta. Tangent, It's pretty straightforward. We have 2 tangent alpha over 1 minus tangent squared. We're looking just for the commonalities between these two. You can see they are identical, where theta is 15. So again, I'm just going to put 15 in here for theta. So I get tangent of 30, which is root 3 over 3, and that's all we're doing here. All right, so those are all the double angle identities. There are 3 half angle identities. So this is the sine half angle identity. So this equals plus or minus the square root of 1 minus cosine theta over 2. We're doing the same thing. We're looking for whatever our problem is to match that perfectly. So you see here it does. All the components are the same. Here my theta is 90 degrees. So I can now plug that 90 in right there. So I get sine of 90 over 2, which is the sine of 45, which we know is root 2 over 2. And if you were to solve this in here, you would get root 2 over 2 as your answer. So that's the half angle for sine. Again, we're really just doing some matching here and then solving once we figure out which identity it is. Here's the cosine half angle formula, and an example for one like this might be, an example for one like this might be plus or minus the square root of 1 plus cosine 60 over 2. So we see this matches up. They are identical, so my theta here, I put here, so I get cosine of 60 over 2, cosine of 30, which equals root 3 over 2, which would be my final answer. So the last one we need to look at is tangent. Notice the half angle for tangent has 2 separate identities, so either one of those, we go back to our half angle for tangent. So we might see 1 minus cosine 90 over sine 90. This is an example. And if you see, it matches up 100%. My theta is 90, so I have tangent of 90 over 2, tangent of 45, just through simplifying, which equals 1. And again, if we were to work out this here, you would see 1 minus cosine 90 is 0, over sine 90 is 1. So even if you did it here, you would get the same answer. So those are the multiple identity trig identities for the double angles and the half angles. I hope this helps you out with your homework. Thanks for watching. Have a good night.